All right, so today we're going to do a couple of things. The first thing that we're going to do is the last lesson in Chapter 5 is number patterns. You have your Chapter 5 test on Thursday. Tomorrow you will get a study guide. I've already recorded a video because Miss Adams is going to be here tomorrow. I've recorded a video going over the first. I've recorded a video going over the first 15 problems in the study guide, and then you're going to do the last 10 on your own. So you'll be able to work through that. Make sure that you go through the study guides, because if there's something you don't understand, you want to know before you get to the test. The study guide and the test are very similar, the same types of questions. And the key to this test is going to be understanding what the question is asking. Right? You guys are really good at factoring. You understand what factoring is, but you need to recognize when they're asking you to factor. Right? You need to recognize when they're asking about multiples. You need to recognize when they're asking about prime and composite numbers. I would definitely be looking over the divisibility rules, because those are going to be helpful on this test. How do I know if 2 is a factor, if 5 is a factor, if 6 is a factor, if 3 is a factor? So be looking at those things. The other thing we're looking at is number patterns. Now, we've been doing a pattern a day for the past couple of weeks. And each pattern has a rule. So here, they give us the rule, and we write the pattern. Give it a second to focus. All right, so we are starting on page 217. All right, my rule is subtract 10. I'm going to start with 100. So here is my 100. And now if I subtract 10 from 100, what do I get? 190. So my next term, oh, it's just 90, sorry. My next term is 90. If I subtract 10 from 90, what do I get?
80.
If I subtract 10 from 80, what do I get?
70.
If I subtract 10 from 70, what do I get?
60.
All right, so when I'm writing this pattern, the pattern is 100, 90, 80, 70, 60. That's right, and I can keep going. All right. So my rule is multiply by 2. My first term is 4. What will my next term be? If I multiply 4 times 2, what do I get? 4 times 2 is? 8. All right, and then I multiply by 2. 8 times 2 is? 16. All right, and I multiply by 2. 16 times 2 is?
32.
Then I multiply by 2.
64.
Now, what is the difference between multiply by 2 and skip count by 6? If it's telling me I'm skip counting, what am I actually doing? I'm adding 6. So this would be like I'm doing my 6 times tables. So 12, and then if I skip count by 6 or I add 6, what's the next number? 18. What's the next number?
24.
Yes. Chances are very good it's not a number that... Oh, actually. Hello? Yes. Hi. Yes. Okay. Okay. And then I say 2, right? Okay. Okay. Good deal. All right. Thank you so much. All right. Oh, you guys should be done with this now.
I'm done.
You're done. Tell me the next number.
24.
Okay, the next number?
30.
The next number?
36.
Oh, look at y'all. All right. My rule is add 7. My first term is 3. What's my next term? 10. Okay, because I'm adding 7. What's my next number?
17.
What's my next number? 24. Okay, we'll slow down just a little bit.
31.
We're gonna wait just a second. All right, my next number.
31.
My next number.
38.
My next number. 45. See, you heard wrong. All right, we're not going to go all the way 12 numbers out because y'all seem to have this. All right, my rule. Shh. Shania, you can scoot your desk back a little bit. All right, my rule is subtract 5. My first term is 94. All right, what is my next term?
80.
89, because I'm subtracting 5. What is my next term?
80.
What is 89 minus 5?
84.
84. Do you see how your basic addition and subtraction facts would be helpful here? Yep. What's my next number? 79. What's my next number? 74. Do you see there's another pattern developing? What's my next number?
69.
What's my next number?
64.
All right. All right. This next rule is I subtract 2, then I add 3. So my first term is 6. What do I do first? I subtract 2. So what's my next term? 4. Then what do I do? I add 3. What's my next term? What's my next term? 5, because I subtract 2. Now what's my next term? 8, because I add 3. What's my next term? Oh, what is this pattern?
It's repeat.
Well, no, it's not gonna. Okay, so let's see. That was subtract 2. Now what do I do? Add 3.
9.
What do I do?
Subtract.
Subtract 2. What do I do?
I thought it was 6.
Oh, it should be 6. No, subtract 2 is 7.
And then you add, you get 10.
Add 3. All right. All right, let's look at this last rule.
I subtracted 3 instead of 2.
Oh, well, then you did it wrong. You've got to pay attention to the details. Math is about paying attention to the details. And the things where we use math is about paying attention to the details, right? Where do we use math in the real world? First place is the bank. I need them to pay attention to the details, don't I? I don't want them losing my money because they're making careless mistakes. Where else do we use math? They use math at the doctor's office when they decide how much medicine to give me. I don't need careless mistakes happening there. I don't need my pharmacist making careless math mistakes. I don't even want the cashier at the grocery store to make careless math mistakes. I need to make sure I get all the money back that I'm supposed to get back. So, math is about precision. More than speed, it's about precision. It's about being careful and paying attention to the details. All right, this rule is add 2 and then add 1. My first term is 12. What do I do?
Add 2.
Add 2. So 12 plus 2?
It's 14.
And then I add 1. 14 plus 1?
It's 15. 17, 18, 20, 23.
All right. Good job. Not permanently. All right. So here, all right, so we are going to look at page 220. And what I want to do is go through these word problems and look at what it's asking me to do. So we're not necessarily going to solve the problem. We're going to talk about what we'll use to find the answer, how we'll solve the problem. All right. So Erica knits 18 squares on Monday. She knits 7 more squares each day for the rest of the week. How many squares does Erica have on Friday? What am I doing here? What's it telling me? So let's say I draw a little diagram. So I have Monday, Tuesday, Wednesday, Thursday, and Friday. All right, and she has 18 squares on Monday, and then it says she knits 7 more squares each day. So she adds 7 squares each day. What skill is this looking at? What did they do here?
18.
They gave me a number, and then they gave me a rule, and they said, here's my pattern. Now find the fifth number in my pattern. That's what they told me, right?
The next one is the big one.
Because I have to go. 18 plus 7 is?
24.
Is 25. All right, 25 plus 7 is 32. 32 plus 7 is 39, and 39 plus 7
Equals 46.
is 46. So on Friday, she has 46 squares. All right? So when I look at this problem, yes, I do. Because if I put a T, then how do I know which is T or which is Thursday? So I use an R for Thursday if I'm just doing one letter. Because T, yeah. So, yeah, that's why I have an R for Thursday.
You could have just put it like.
I could have done a lot of things, but that's really not the point. I put an R for Thursday because that way I don't have two T's. It's not something we need to get wrapped up in. What we need to be wrapped up in is this question gives us the starting number and a rule to create a pattern. And that's what I'm looking at, is that pattern. All right, 15. James works in a flower shop. He will put 36 tulips in vases for a wedding. He must use the same number of tulips in each vase. How many tulips could be in each vase? What is this question asking me to do? It is asking me about the factors. It's asking me what the factors of 36 are. Okay? It's asking about the factors of 36. So it's really, in essence, I'm going to do a factor rainbow, and all of the numbers on this list will have to be on my factor rainbow list. So where do I start with my factor rainbow? 1 and 36. What's my next number? 2 and what is it? It's 18. At this point, we've done 36 so many times that somebody in here should remember that 2 times 18 equals 36. All right. 3 times what equals 36? 3 times what? 2 times 18 equals 36. 3 times what? 3 times 12. All right, what about 4? 4 times 9. Is 5 a factor of 36? No. What about 6? Yeah, 6 times 6. All right, so let me look. Are 1, 2, and 8 all factors of 36? They are not. 8 is not. So 2, 4, and 8? 2, 4, and 9? Ah. Yep, 2, 4, and 9. 6, 12, and 16? No. All right. Number 16 asks me, what multiple of 7 is also a factor of 7? There's only one answer to this question for every single number.
1.
1 is a factor of 7. Is 1 a multiple of 7?
No, 14. 0.
All right, we got to go back to the multiples. What are the multiples? What's the root of multiple? It's multiply, right? When I multiply, I'm counting by that number. So when I do the multiples, I start with 7 times 1, and that's 7. Then I go to 7 times 2, and that's 14. Then I go to 7 times 3, and that's 21. Now, which of these numbers is both a multiple of 7 and a factor of 7? 7 is a prime number. It only has 2 factors. What are the 2 factors of 7? What are they?
1 and 7.
It's 1 and 7. Which number is on both of those lists? 7. 7 is a multiple of 7 and a factor of 7. Oh, a movie that I love has a scene about this. All right, so hot dogs come in packages of 6. Hot dog buns come in packages of 8. Antonio will buy the same number of hot dogs as hot dog buns. How many hot dogs could he buy? What is this question asking me?
Multiple?
It's asking about multiples. All right? And it's asking about common multiples. So how am I going to find the common multiples?
You do 6 times 8?
Well, 6 times 8 is a common multiple, but that's 48. No. It's 48. And 48 is not one of my answer choices. So I have to find the multiples of 6 and the multiples of 8. You guys are really going to need to look at and think about multiples in the next 2 days. All right, so what are the multiples of 6? Let's keep going. Let's give me the multiples of 6. 12.
18.
24. Now let's go to 30. All right, let's do the multiples of 8, and we'll go until we run into one of these numbers. So 8, 16, 24. Oh, I ran into it. There is my lowest common multiple. So if I buy 24 hot dogs, then I'll have exactly the right number of buns. All right. Sean has 54 flower bulbs. He planted all the bulbs in rows. Each row has the same number of bulbs. How many bulbs could be in each row? What is this asking me to find?
How many bulbs could be in each row?
Okay, now what skill am I going to use to find it? If I'm putting things in rows, what am I doing? I'm building an array, and what does an array give me? right, 54 is the total number that I have, correct? Now, it wants to make a rectangle or an array of that 54. That's what I'm doing with the rows. So Jeremiah, if I want to figure out how many rows I can put things in, what will I find for 54? All right, guys. You're taking a test on chapter 5, yes? So the test on chapter 5 is going to test the skills that we learned in chapter 5, right? I'm not going to bring in something else and make you do something that we haven't been practicing for 2 weeks before Christmas and now 2 weeks after Christmas. So tell me the skills that we have learned. There's basically 3 skills. We've learned about factors, we've learned about multiples, and we've learned about number patterns. Now, in that, we've talked about prime numbers and common factors and common multiples, but there are basically 3 operations that we've been working on. Factors, multiples, and number patterns. If I have 54 flower bulbs, and I want to put those bulbs in rows, you know, like this. So I want to build an array. And it's saying, how many rows could I do? I have to have the same number in each row. How many groups? What is that asking me to do? Factors, multiples, or a number pattern? Is it asking me to break down the 54 or build the 54 up? Okay, I'm not going to use 54 because that will take a long time to count. All right, I'm going to use 24. So I have these 24 cubes. I want to put these cubes in rows so that each row can have the same number of cubes. And then it's asking how many could be in each row. Well, the first thing I could do is I could make one row of 24, right? Yes? I can make one row of 24. So I have one row of 24. What is that? All right, well, let's keep going. I could have two rows of 12. Correct? So I could have 2 rows of 12, or I could have 12 rows of 2. Okay. I could have what?
So you're trying to find a number that equals 54?
No. What I'm trying to do right now, I have left the problem in the book. I've left that problem because the key to a math test is not just that you know how to add, subtract, multiply, and divide. The key is that when it asks you a problem, because a lot of the problems on your math test are word problems, that you know what you're supposed to be doing. And said, am I factoring, am I using multiples, or am I doing a number pattern? You guys looked at me like I was speaking another language. Like you had no clue what to do. So I'm trying to show you with a smaller number. I'm visualizing the problem for you. What am I doing here? Am I doing multiples of 24? Am I doing factors of 24? Or am I finding a number pattern? So I have 1 and 24, 2 and 12. I can have 3 rows of 8. Right? So I could have 3 rows of 8. All right? I could have 4 rows of 6. So if I was doing this with 24, I could have 1 row, 2 rows, 3 rows, 4 rows, 6 rows, 8 rows, 12 rows, or 24 rows. Did I factor 24? Did I find the multiples of 24? Or did I use a number pattern? The multiples of 24 are when I count by 24s. 24, 48, 72. So when I factor numbers, they get bigger. They don't get smaller. Or when I do multiples of numbers, they get bigger, not smaller. Factoring numbers breaks them down. I just found all the factors of 24, right? Because I had 1 row of 24, I had 2 rows of 12, I had 3 rows of 8, I had 4 rows of 6. If it gives me a number and it tells me that I want to put it in rows or make a rectangle, it's asking for the factors. Because it's breaking it down. So if I go back to my problem, and he has 54 flowers. All right, so I'll take out my 24 here. He has 54 flower bulbs. He plants all the bulbs in rows. That's equal groups. Each row has the same number of bulbs. That's equal groups. How many bulbs could be in each row? So which of these could be a number of the rows that he has? This question is basically which of these numbers is a factor of 54? 8 times what is 54? I can use my divisibility rules to solve this. Or I can make a factor rainbow. I'm going to make a factor rainbow. 1 times 54 is 2 a factor of 54? Yes, it is, because 2 is even. So 2 times, let's see, 25 is 50. 26 is 52, so it's 27. What about 3? Is 3 a factor of 54? Well, if I add 5 plus 4, I get 9. Is 9 a multiple of 3?
Yes.
It is. So 3 is a factor of 54. Let's see. 3, 18. All right. What about 4? 48. No, it is not. 5?
No, of course not.
No. 6? Well, yep, because 2 and 3 are both factors of 54. All right? So, which of these numbers is a factor of 54? It's 6. So if it says I have a number of something and I want to put it in rows, what am I having to do? It's asking about the factors. If I have a number of something and I'm putting it into rows, it's asking about the factors. All right, we will stop here. You may put your MacBooks away and get your snacks out.